Welcome to Fragmented, a software developer podcast where we talk about building good software and becoming better developers. My name's Donn Felker.
And I'm Kaushik Gopal.
Welcome to the show. I feel like we're falling into a groove finally, Kaushik.
I know. We're starting to get more episodes. It's starting to get interesting. Things are kicking back. I think, we finally might be over at least our hiatus.
That's true. But I think it's also really interesting regarding today's topic, because it's something that I've been very passionate about, and I know you have as well. So what are we going to be talking about today?
So it's interesting. We get asked a lot about, some of the newer Android technologies. And obviously, even if you just watched the last I.O., Jetpack Compose is on everyone's mind. And we've actually talked about Jetpack Compose in a previous episode. We actually talked with Leland Richardson. That's episode 171 and 196. And those are great episodes. He goes into the details, the internals, how he thought about it as he worked at Google in building this library up. But one thing we felt might have been missing is it would be nice to actually talk to someone who's equally adept, who's like, as I like to call, a compose wizard or magician, but on the other end of the spectrum. So someone who actually uses Compose and who is really pushed it to its limits. And we have the perfect guest for that.
Yeah. And so without further ado, I'd like to welcome Vinay. Vinay, welcome to the show.
Hey folks, thank you so much for having me. Excited to be here.
Definitely. So for folks that aren't familiar with you, would you please basically provide, your name, where you work, kind of how you maybe got into Compose and et cetera, and then we'll kind of take it from there.
Sounds great. So I'm Vinay. I work as an engineer at Airbnb, and I tend to focus on consumer products. So I've also spent some time at Snapchat and Spotify before that. And my journey with Compose started fairly early. Back in 2019. It's almost been 3 years.
Wow.
And it started because of public speaking, which I think is a great forcing function. And so in 2019, October, I was giving a talk at DroidCon about architecture agnostic UI development.
I remember that. Yeah.
Oh yeah, that's actually how I met Kaushik, or spoke to Kaushik, because he had similar interests and he had actually written a blog about a similar subject. And so the idea that I was trying to highlight there was that if your UI is dependent on state, it doesn't even matter what you're using to describe your UI, and you can easily swap things out. And so as an example in that talk, I replaced the view system with Compose, which was still in dev preview. And in fact, it was dev preview 03, because I very clearly remember it was a completely different beast altogether. There have been so many changes since then in the API and how Compose is even implemented in the optimizations they've brought in. But it was very clear to me that this is something that's going to stick. I had not felt this much joy in writing Android code since a very long time. I think the one moment I remember was when I started Android. It gave me the same kind of excitement. And so I just kept going down the rabbit hole, kept building tools that were solving a pain point that I certainly had, and I hoped that it would solve it for the broader Android community as well. And that's basically what started this Compose love affair.
And for folks who don't know, Vinay is also a GDE, semi-recently minted, if I remember correctly.
Congratulations.
Thank you.
And he talks about some of these side projects and going down the rabbit hole. We'll try to cover some of these as we go through the episode. But I will say some of this is really good. He has a talk that's called Learning Jetpack Compose by Example. And that's, in fact, if it's one of the talks that if folks are hey, I want to get into Compose, where do I start? There's so much resources. Everyone's talking about it, but then you find details at different dimensions, right? At one, you hear the folks like Leland who talk about the internals and the compiler, and then you have people who throw a hello world. Where do I start, right? And his talks are one of those talks that I love distributing to people, because he's done the work of just giving you that the right amount of information to get into it. So that's one.
So that's very kind of you, but I do want to give out a fun fact. It's actually modeled behind a talk that Kaushik gave, funny enough. It was called RX Java by Example. And the name also is homage to that almost. So thank you for giving that talk. I think it's one of the best RX Java talks you can watch even today, even though it's been so long.
That is high praise. Thank you so much. But putting the spotlight back on Vinay, because Vinay will come off as being very like, oh, I just did this on the side, but some of the stuff he's done is like mind blowing. But I was looking at it and I was like, geez, like how many hours in a day do you get, right? Jetpackcompose.app is like a fun URL that people should check out. We'll add it in the show notes, and we let Vinay do the honors of telling us more about this as we get through it. But the one that really where I was like, oh my God, mind blown is like ShowKase. That's another library that he wrote, all to do with Jetpack Compose. Vinay, do you want to like maybe quickly give us like a rundown on what those two things are?
Yeah,
absolutely. So I think it might have been June of 2020. So exactly 2 years. I think the birthday is coming up for this website, the 2-year birthday. And I had this problem where I constantly wanted to figure out what API I need to use in Compose. I clearly understood what I needed to use in the view system, but there was no mapping to what I should be using in Compose. And so I did what most engineers do. I ended up using a hash map. That is essentially what my first tool was. It was basically very IFTT-esque. If you know that tool, if this, then that, essentially that's what I modeled it after. And so you essentially selected which API in the view system or the classic Android system you want to use. And I give you the Compose equivalent of that. That was the first tool on the site. Since then, I've added more features and tools, things like FAQs, quick bytes, Compose catalog, because there was so much innovation happening in the community and there were a ton of projects around Compose, but no way to discover them and like find them out. And so I'm just adding all these things to the site and making constant developments to this day. Like this site is being maintained and it's a passion project that I continue to spend more time than I probably should on. So that was my first project. It was actually something I actually did something before that, which was learn Jetpack Compose by example, which is a GitHub repo where I do something similar, but I show you all the common Android tasks that you do in code with comments. So each example is treated as something that's super encapsulated. So I make no assumptions about what you know in those examples. Every line I try to document and comment so that you can just read through that, and it's almost a tutorial in some way, but not really because you're reading through code. So it might not be for everyone, but if you're something that loves to go in the weeds, that's the repo that you want to look at. And the examples I wrote in that repo is what I highlight even on the site. So when you select, let's say, recycler view, I'll say that the Compose equivalent of that is lazy column. And I'll also point you to an example from this repo that I mentioned. So there's some upselling going on, even though they are free projects, but I'm cross-linking them essentially and trying to integrate my projects in some way.
This is such a service. Like seriously, the amount of work, because it in the theory seems like simple, right? Like just okay, hey, you just have a map, but the amount of diligence and work he's put into this is fantastic. Yeah. Like you said, you can link to specific docs from the repo, and he has tips. It's fantastic. Thank you so much for this. This is quite the service.
We'll put all the links of this stuff in the show notes for the folks listening. So check out the show notes if you want to check out all of these different tools. And again, like Kaushik said, thank you for creating them. These are fantastic.
I've learned from the best, so this is my way of giving back. I mean, y'all have been doing this podcast for, 7-8 years, and y'all have basically up-leveled the community. So thank you so much for even creating this platform.
Thank you.
That is very kind of you. What's ShowKase? Tell us a few things about ShowKase.
Yes. So this is also a library that I open sourced in 2020. I think it's very clear that I was excited about Compose because all these projects kept going out one after the other. It was just me being in the zone, so to speak. And so ShowKase is something that I open sourced with Airbnb. And it was based on a project that I saw internally. So I take no credit for the idea itself. But I applied that to Compose, and there were a few reasons. So anytime there is a declarative system, and I think the most obvious example, and probably the first example, is React, it's very easy to create new components. And so when you're alone, you will probably create 10-20 components, and that's your app. Now scale that up to maybe 100 engineers, which some of the companies do have that many engineers. Focused on just Android, by the way. Over time, you will end up in a situation where you have thousands and thousands of components. And one of your goals, hopefully at that point, is that we want people to reuse as much as possible. Maybe you have a design system that you want to somehow highlight. And so the solution to that problem that most companies have is that they'll create some kind of a component library that you can browse through on some debug setting in the app. And every company is maintaining this component browser or your UI element browser manually. Either that, or they might create some tooling which over time automates some things. But the perspective I had was that why should 103 companies create 103 variants of the same thing? And so it was very clear that if not me, someone else is going to build this. And so I started going down the rabbit hole. With most of my projects, they usually start as me wanting to learn something. And so the only reason I started Jetpackcompose.app was to learn React. That was my only goal. I had no other goal. And that was interesting because I had gotten comfortable with Compose, and so I understood what declarative UI was. And I wanted to apply it to a new system because my hypothesis was that, you know what, it might be easier for me to pick it up because I understand the mental model needed. With ShowKase, my goal was to understand annotation processing and to create something that uses annotation processing. And so this felt like a good way of working on something cool, but also picking up some new skills that I had not experimented with before. And thus ShowKase was born. And so just like a one-line spiel of ShowKase will be: ShowKase is an annotation processor-based library that lets you visualize, discover, and highlight Jetpack Compose UI elements in your code base. And so you can think of it as a component browser where you can see all the components that you've created in your entire repository. You need very little effort to do that. And so what Compose created was something that they call previews, which let you preview something in Android Studio, which is amazing, by the way. Slightly flaky, but let's assume that they fix those problems, which I'm very bullish that all those problems will be fixed over time. I try to make sure that I add first-class support for it. So if you have previews already set up, ShowKase supports that by default. So you need no additional work in order to see all your components in a single place. What preview allows you to do is preview those components in a single file, but it does not give you a snapshot of your entire repo. Plus, it does not let you search through all your components. So if I just want to type, I don't know, avatar card, I can't very easily do that, nor can I see all the styles associated with it. ShowKase makes these things easy.
That is pretty slick. It is quite the... So it's basically like, hey, let's get preview, but let's get it across multiple components and make it easy to sort of like quickly see what these components specifically are.
So it does a few more things, and maybe it's worth highlighting. Now that I have all your components, it's very valuable information, right? So we want to use this to the maximum. And so one thing that ShowKase does is that it creates situations to force your component in certain situations. So for example, I force RTL layout and then I render your component. So you can see what your component looks like when RTL is enabled. I do that. I do the same thing with dark mode. So I force your component to have dark mode properties available so that it automatically renders itself such that dark mode was enabled without actually toggling any setting on the phone. It's happening in the browser itself, in the ShowKase browser.
So cool. Yeah.
So I just want to make sure I understand this properly. So for teams out there that have their own Jetpack Compose components and they want to basically test them out and almost have like an explorer, ShowKase will allow them to have that. Is that correct?
That is correct. Another one-line way to say that is that if Storybook was on Android,
okay,
that's basically it.
Interesting. Cool. Well, we'll put links to the show notes and to links to ShowKase, Jetpack Compose app, and your Learning Jetpack Compose by Example talk into, again, the show notes. But let's hop into it here. I'm really excited to start learning a lot more about Compose from a developer perspective. And I think this is one of the interesting things to me of why we're having you on the show is, as Kaushik said before, Leland has been on the show a couple of times here back in episodes 171 and 196, but we did a real deep dive about the internals of Compose. That's very useful, but from a developer perspective, I want to know, like, why should I even use Compose? If I've already invested a lot of time into XML, what's the point of even using Compose? And then, we can get into actually developing with Compose as well. So let's start with that first question. Why do I even need Compose?
Awesome. So I think this is a very valid question, and I would encourage everyone to question before you make such massive paradigm shifts in your own code base. I think it's very understandable, important why even Google decided to do this, right? So if you think about their perspective, they had invested almost 12 years of development happening on the existing view system.
Mhm.
Their approach was to rewrite the entire UI toolkit from the ground up. And this is a very pure rewrite. They are basically not taking anything from the old system. Very controversial if you think about it. You probably have to spend a lot of time justifying this decision that why are we rewriting everything and throwing away everything that we've done, the documentation, user education, millions of dollars that we've spent in engineer salaries to create all these systems. And so if you think about it, like it had been almost 10 to 12 years since Android APIs were being developed, and specifically focusing on the UI toolkit, inheritance was something that was prevalent. And so every view essentially extended the view.java file, or the view class rather, which lives in the view.java file, which is a 40,000 line class. And so automatically you can imagine that no matter how hard you try to optimize something, like you are getting a ton of work that's probably not needed for a given view. So that's one. Inheritance also makes things hard to refactor, and you need to spend a lot of time doing that. And we've obviously heard this quote which says composition over inheritance. I think you all have actually covered this in one of the effective Java episodes.
Mhm.
And so we know that's true, but the view.java file, which is the basis of UI toolkit, ensures that you can't do that. So from the get-go, you're not using a best practice that we rave about all the time. The second thing was that the UI toolkit was directly coupled in the operating system. And so when you see an Android 12 release or an Android 13 release, all the new updates coming in, let's say, the textview.java file are happening only when these releases are going out. And even though they do smaller releases, it's not that frequent as opposed to a library that can potentially be updated bi-weekly, which is the case with Jetpack Compose. So it used to follow a bi-weekly cadence. For the most part of last year, I don't know what's happening these days. I think it's slightly slower than that. But again, the improvements are going out at a very regular cadence. That wasn't the case before. And so UI toolkit being coupled with the operating system wasn't ideal.
And it's almost like the app compat sort of revolution where it started decoupling from the Android OS, right? Like that was almost like a very valuable unlock for Android developers, right? Where we're like, hey, you get to use the new tools even on the latest sort of operating system, right? And so it makes sense where they were like, well, if we had to move like the entire view hierarchy into like app compat, like we can do that. Or like, we can use this opportunity to like help solve a bunch of other issues. So it almost feels like it all came together. And again, React React has had like a very heavy influence, like we know this, right? So it was the right time, I guess, because everyone was talking about like this reactive kind of UI approach. Everyone's talking about how do I get like, stateless UIs and a lot of that stuff. So I feel, would you say it's fair to sort of say that everything came together and they're like, okay, this is why we basically make the big shift?
Yeah, I mean, they actually considered the option of only moving the view layer into its own library. And as they were thinking about that, they realized that, we have all these other issues. State management is tricky. It's not, our APIs are not Kotlin first. Simple things still require a lot of work. All these reasons led to them deciding that, it's time to rewrite the UI toolkit from the ground up, lay the right foundation so that the next 10 years can be a lot smoother. And we don't have to battle our own APIs, which is not fun.
Oh, for sure, for sure. We forget that these are like the folks working on like the view system at Google are just engineers like us who have shitty days, and parts of the code base that people don't want to necessarily work on. I want to back up though. You said state management, right? Like I think that's a valuable enough point where we should point it out. Why is state management hard? Like, because everyone talks about it. They're like, oh, state management hard. And many times we just assume that, but I want to dive a little deeper and get your insight into like, why is state management hard today?
Yeah, so I would definitely say that there are ways to make that easier, but because it's open-ended, in most cases, you're always trying to make sure that maybe you have a single source of truth already, because I think that's where we've settled on as a community. We've realized that single source of truth is something that we should all care about. Even if you're doing that and you're making sure that you pass that down your layers, you still have to make sure that your view state, which is internal to the view, is essentially also reflecting that. And so I think one example is the alert dialog that I like to give, where you're building the alert dialog with the properties that it needs, maybe the title, maybe the message, some actions. And that's not enough. Even though you've constructed what the alert dialog needs to show, you need to go and tell the alert dialog, hey, can you please show yourself on the screen? So there is a method called show that you're essentially letting that builder know that now is the time to render yourself on the screen. And so this is essentially us saying that even though your view state was saying show alert dialog, you had to do this extra step to make sure that your view was also in sync.
That piece is so important, right? Because like to your point, I think as a community, like the single source of truth, like where we have like a view state, we send the view state and we just bind our views to it. The funny thing is internally, like, and that's where the state management comes, right? Like the way views function today, Android views function today, they internally do have a state, right? And that's, I think, the piece. Like, for example, is it, and I'm watching your talks and just like, this is like the common, easy one to think about, right? You say you have like a class, like, a UI class, like, let's call it the view state that describes, okay, what should happen to the UI. There's still a lot of logic in that binding that goes through, right? Where, like, for example, with the alert dialog, is the alert dialog already currently present or is it like not visible, right? Well, if it's not visible, then okay, let's first make it visible, right? The other thing is like you naturally think, okay, let's bind the content. Maybe the text on that has to change. Okay, well, do you have like old text or do you have new text? Oh, well, you have old text. Let's update the text. But, sometimes as developers, you can update the text, but forget to check if it's actually showing or not showing, that inherent process of just like trying to map this view state, the internal views state to your single source of truth requires that binding logic that you have to write, right? This is not something that comes with the system. And the promise with Compose is like, hey, that whole layer is taken away from you. You can just literally like, synchronize your Jetpack Compose allows you to synchronize your state with something that you define, as against, having to write the logic to do it, if that makes sense.
Yep, that's spot on.
Yeah. So a lot of the bugs in the binding logic, a lot of that stuff is sort of taken away. How in practice, how is it like with Compose, right? Like I know that's the promise, but in like, this shift in mindset with Compose, how does it work? Can you as easily just bind it to this view state that you want? Say I have, because, and like we talked about this in like the early days, like, the first time we had a chat, like the whole unidirectional state flow, or making sure, okay, we have this thing that describes the view state that's pumped up, and it doesn't matter what your view definition technology is. How is it in practice today? Like, does Jetpack Compose actually just simply beautifully bind to any object that you specify? Or does it in some ways force you to sort of like say, no, but Jetpack Compose only takes in the model this way, so you have to describe it this way? If my question makes sense.
Sort of. And I'll try to take a stab at what you were describing. And so there is a concept called prop drilling, which again comes from React, if I remember correctly, where you're essentially saying that you pass down props to the components and you only pass the props that a component needs. And so ideally, you just want to make sure that you're passing the data that a component needs. And as an example, let's say that you have a data class called news metadata that has 30 properties. Instead of passing this entire data class to a component, you will only pass what it needs. And maybe it just needs 3 fields. And so if you're just passing the fields it needs, one, most likely you are relying on primitives. If not, that's fine too. But most likely you're relying on some primitives. And so your composable function, which is the lowest granularity to describe a UI, becomes fairly reusable. It also becomes fairly easily testable because all you're passing is parameters, and it's very easy to update that in a test environment as well. Maybe take screenshot tests, maybe take tests using a certain snapshot that your compose was in. And so with assuming that you're following these practices, following prop drilling, making sure that you just pass parameters down the chain as much as possible on the bare minimum, it becomes fairly easy. What Compose also does is that in the name itself, you see that it's trying to say that it's composable. And so it's giving you the building blocks needed to render some of the most common UI, and you can use them internally to build on top of. So you don't really have to deal with the lower level details. And binding here is merely passing a parameter. That's essentially all that is needed to binding.
And maybe let's like jump into some of the stuff. You mentioned some of these snippets, right? For example, composable, the annotation composable. And in your talk, you talk about like set component. Can you like give us a let's talk about the composable annotation, because I think, you said that's like the lowest bit of granularity. Why even use composable as an annotation, right? Why couldn't have they just made a keyword or something? Kotlin allows you to do like crazy things, and I think you pointed this out, suspend. You have a suspend keyboard. Why didn't they just make it something like that? Why did it have to be an annotation? I'm curious. And what is composable? If you can just give as much as you can over audio.
Yeah, so this is a very, very valid question, and unfortunately not well documented. Maybe I might be confusing you. Let's talk about the add composable annotation first, and then we can jump into why they decided to use this annotation as opposed to a keyword. So add composable is the lowest granularity needed to describe UI. You annotate this on a function. This is the magic sauce or the secret sauce that essentially tells the compose compiler that you're trying to describe UI. It's just a way of signaling to this Kotlin Compose compiler that everything that you need to do to enable Jetpack Compose, go ahead and do it with this function because this is a special function.
And this is applicable only on functions. I can't just throw composable into like a variable or something or a data class. This is specifically meant for a function, and it adds special powers to a function alone.
To a function alone, I think they've also added this on lambdas, which are essentially functions itself. So you can easily add it to a lambda too, and then hold that reference in a variable if you wanted.
Got it. That's fair. And so you said this basically helps. This is the secret sauce to it all, right? So composable, you said, helps define the UI, right? How exactly does it do that? And can you give us a brief idea of how that works?
Yeah, sure. So I can speak to it at a very high level because there's a lot of pieces to compose and multiple layers that depend on each other, essentially in a linear fashion for all of this to work. This was very intentional, by the way they've layered it. It is to ensure that the Android UI toolkit isn't the only toolkit that Compose works with. And so they certainly had multi-platform in mind when they were creating these abstractions. And there are already examples of this in production even that are using Compose across different platforms. Like there's a web variant, there's a desktop variant. I know there's an iOS variant in the work in some companies that I don't want to mention. It's not my company, by the way, just so that we are clear. But this is from conversations that I've heard in the community. So it's a very exciting time in general. Coming back to your question about how this all works. And so when you annotate something with the add composable annotation, what it tells the Compose compiler, which is the very first player in this conversation, is that now you can do whatever you want to do with it. What the Kotlin Compose compiler does is that it's going to transform the add composable functions with some extra metadata. Because this is a compiler plugin, it's able to actually change the intermediate representation or the Kotlin IR. You've probably heard of Kotlin IR. It means that the way you're describing your code in some representation that's, again, abstracted so that it can be multi-platform, it allows it to change that definition and add more properties to it. So what the compiler is doing here is adding things like the composer as a parameter to this function. The end user cannot see this. So this is completely invisible to the end user, but it's added in the representation of code so that the next step can then use this information and do whatever they want with this extra metadata that was just added. So that's player number one, the Compose compiler, which is responsible for transforming your composable function, adding more metadata so that other people in this pipeline can now use this metadata in creative ways.
So it's interesting. There are different pieces, and we'll try to get into this as much as we can. But Jake Wharton had this post where he talks about the naming, and I think it goes into this, right? Compose is both the compiler and the runtime. But before we get into that, right? What you're saying is the Compose compiler is basically what does this magic, right? And is that specific to Android, which means when you want to do it on iOS, would you have a different compiler of sorts, or no, this specific compiler is applicable to everything? And then there's the runtime, which does a different piece. That's also another point of confusion for me, by the way. We have Compose compiler, we have the runtime, we have foundation, we have the UI, we have all these things. So can you help sort of structure that? How do all these players fit?
Yes, absolutely. So Compose compiler, again, it's an abstraction, so it should be able to be used in any platform. And let's assume that the compiler has done its job, which is added metadata to this intermediate representation. Then, and this is happening at the compilation step itself. The next player is the runtime, which again is essentially at a very an oversimplification of the runtime would be that it's managing the UI tree in some ways in a multi-platform fashion again, because trees can be applied in any UI toolkit. And so I would say that the magic isn't just the compiler, it's the compiler plus the runtime, because that's equally important.
And this is the React diffing piece, right? Which is like, hey, just how do I detect changes only on a portion of the graph, or like, on the node, which nodes have changed and need that updating, so to speak. That's this piece, right?
Exactly. Yeah, that's absolutely right. So all the composition, recompositions that you've probably heard, like that's where this is happening. What the runtime does is that, by the way, all the annotations that you see, so the at composable annotation, at stable, at immutable, we don't have to dive into that right now. But all these annotations are a part of the runtime itself. And so the way it works is that the runtime depends on the compiler. And because the runtime wants the compiler to be able to do this processing. And it's essentially a building block of Compose, especially the state management piece and the tree management piece. And that's what the runtime does. So all the recompositions, all the snapshotting, the updates to the tree structure, all that is handled by the Compose runtime. And again, this is a very critical piece. And I say magic, but I say it in a very positive way, because there's some negative connotations associated with saying magic. But yeah, like runtime is as critical as the compiler, in my opinion.
And then there's the, we have foundation, and I guess what UI and animation and material. Where do these fit in? I mean, I'm asking this question mainly from a developer, someone who's going to be using this library, and I've maybe seen these names inside of a Gradle file somewhere. Yep. I've seen I've seen them inside of an import statement. I'm like, all right, foundation, and I have material. How do I tell these apart, or is there a good way to tell them apart at all? And what are they for?
Yeah, so from the perspective of an end user, you will not be dealing with the compiler at all. So Congratulations, you have one less thing to worry about.
Thank goodness.
In terms of the runtime, it exposes state primitives. And so Compose has state as a first-class citizen, which the Vue system did not previously. And so that is a part of the runtime, and that's the only part that you need to care about. Like you've probably seen keywords like remember and mutable state of, like those live in the runtime library. And so you'll see it in your imports. But again, that's the only thing you need to care about as far as the runtime is concerned, at least from what I can think of at the top of my head. The next layer is the UI layer, which was counterintuitive to me because I would have imagined the foundation to be the next layer because, hey, it says foundation. But the UI layer is the next layer. And what Compose UI artifact gives you is primitives essentially for building UI. So it's the building blocks for building UI. Things like text style, font family, modifier, which honestly are going to be your best friends. The layout itself. These are all what the Compose UI exposes. You'll be using these as well, but for the most part, you will be dealing with the foundation layer, which is opinionated but not material design implementation of some composable functions. The key part here is that it's not the material design implementation, just the basic composable functions you would need for building UI. Some examples would be box, row, column, lazy column, which is the recycler view equivalent. In addition, it also has the implementation of the modifiers. So if you want to add padding, that's probably going to be the padding modifier that lives in the foundation artifact that Compose exposes. And so you'll see that it's essentially a linear line of dependency, and material is at the highest level. And so just to summarize, material will depend on foundation, which will depend on UI, which depends on runtime, which depends on the compiler. And so they are all dependent on each other and built on top of each other in a composable fashion.
Nice. And just a quick question. Say like I'm starting off as like total like noob Android developer, right? Do I have to explicitly add the compiler, runtime, UI, foundation, all these things? Or does it just automatically come with new projects? Or is there just a single dependency that says Jetpack Compose, give me it all,
Yeah, so I think the foundation library, the Compose foundation library has these API dependencies. So if you're using foundation,
makes sense,
you automatically get some of these libraries that you need. It has gone through some changes, so I don't remember what the latest is, but I know they've cleaned that up a fair bit. And you should need very few dependencies. material is a separate dependency. So if you don't want material design, you can completely avoid that dependency altogether, which again is what you want to do in an ideal case, because we care about app size. Most apps of like reasonable scale care about app size. So you want to avoid what you don't need. And having this modular structure ensures that the other artifacts, because there are tons and tons of artifacts. There's something for constraint layout, something for motion layout. You can avoid those if you don't need them and save that valuable app size space. I mean, these days R8 gets rid of most things anyway.
It's
But
true.
I prefer not having these in case there is ever some bug somewhere, right?
That's fair. So, I mean, thanks. That's super helpful. It just helps understand like how these things play, right?
It does, yeah.
Another question I had more from like a basic developer perspective, right, is with Compose, like you mentioned material, you mentioned foundation, you mentioned UI. Say I'm like building my app, right, and I have like buttons, but like my app, the buttons, at least like at Instacart we want green buttons or whatever, right? Like this is where the design system comes in. What is the recommendation today? Like, am I supposed to just copy paste these buttons everywhere? Am I supposed to create like a separate library, like the equivalent of what foundation is, or do I have like my version of material? So I don't use the material styling, but I have my own thing, and then create those buttons and reuse it. What is like the general practice, or like the recommendation, if that makes sense?
I hate to say this, but as I've grown as an engineer, I've learned that the answer to most question is it depends.
I knew that was coming.
So this is this is the boring answer. In practice, you want to, like, just from a principles point of view, you want to make sure that you reuse what you can while not trying to make sure that you don't pigeon yourself into a decision. And so you probably have to take your use case into account, think through what you might want to do in, like, let's say 2 years from now, and take decisions based on that. If you have a design system, in some cases I've seen people use material as the basis of their design system and build on top of that. And again, it depends on what kind of company you're working at, the amount of design horsepower, which might not want to reinvent the whole thing. Maybe material works for them, which is not a bad thing. And there are also companies that are fairly large. We can use examples like Instacart and Airbnb that have a lot of designers working there, that has their own custom design system. And so in those cases, maybe you do not want to get all the stuff that material is doing and you want to build something custom. I don't think there is a one size fits all, but I will say that for most use cases, especially if you're working on your own apps or working for smaller apps, material should get you pretty far. If not, you can always create your own design system, which is very trivial to do with Jetpack Compose. And one of the things that they've over and over again tried to highlight of how easy it is to build your design system. I know some very popular companies that have done phenomenal work in the Android ecosystem. They decided to build their design system with Compose. So that was their first foray in Compose, where their entire design system was using just Compose and nothing else. Made a ton of sense. And again, they decided to not use material because it didn't make sense for their use case.
Interesting. I know in my personal experience, what I've done a lot of the time is just to make it simpler. And I think you kind of touched on this a little bit, is I've taken material and then extended material to implement, perhaps just simple coloring to match the brand of a client's application using things in Jetpack Compose. And that was pretty useful. And the time that I spent over in React, I spent a couple of years in React, I got really used to creating custom components, which are basically views, if you think about it, and do things. It's very similar to Jetpack Compose components. And it allowed me to easily say, all right, I want a button here, and I would just import that button and use that button. Now, I think Vinay, you made a very good point. You need to think about these things in the time frame of 1 to 2 years of how are you going to be using these things, what functionality do you need, how can you extend this, etc. So it's something you do have to think about. But I have also found that when you do start finally creating yourself a nice library of these components to use, it can make development a lot faster for teams when they're moving forward.
Yeah, Ben, I think one quick point I want to add here is that material is also fairly opinionated, right? And so when you look at the color scheme, they have strong opinions about what colors, or rather the semantic naming of color should be. It's primary on primary, secondary on secondary. Maybe your design system has its own opinions about semantic naming. In those cases, material is a non-starter for you. And so it's very easy to make that decision because you know that it can't support the use case you need.
Yes.
Right.
Completely agree. So we got a couple of things that we just want to hammer through here real fast, even though I think one of these topics could probably take an entire episode, but we'll at least touch on it while we can. And that one is the thing that really brought me and gave me the aha moment back when I worked with React, and then when I worked with Flutter, and then when I finally hopped into Compose. It was just like, I just felt at home after having so much experience with these other technologies that used unidirectional state flow. So I was kind of wondering if you might be able to kind of walk us in an elevator pitch through what, the unidirectional state flow is inside of Compose.
All right, I'll try my best to take a stab at explaining this. And so the way unidirectional data flow is described is that state flows in one direction, which is top to bottom, and events flow in the opposite direction, which is bottom to top. And what that means is that you want to make sure that any state that is changing, you're propagating it in a way that's going to UI top down. All the UI is doing is propagating events back to the state. And so as an example, let's say that you have a state that has a name, which is essentially a string value. You're passing this as a parameter to a composable function, and the composable function is able to render this name on screen. Now you also pass a lambda to this composable function where you're saying that this button was tapped. And when this button is tapped, you just let the view model know inside this lambda that this button was tapped with this. Maybe you're just toggling the visibility or something.
Yeah. Okay.
And so you're just letting the state know through an event, but you're not actually changing the state in the view itself. And so the UI layer remains pure in some ways because it's not trying to change the state. You want to change the state in a single place. And so that's where the single source of truth and unidirectional data flow comes in this conversation. This ensures that, again, you don't have to do this synchronization dance because you're changing things in a single place. Everyone has a clear responsibility. And it also makes testing very easier because everything is isolated from each other. And so you can test the state management logic in isolation. You can test the UI logic in isolation. And this is the ideal world that we wanted so hard to have in the old system. And we were able to do that also over time after a few iterations, but still it required a lot of work on our end.
Right. One of the challenges with doing this in the old world, right? Like you rightly said, we sort of achieved this with a couple of iterations in the Android community and the world, right? But one of the common issues that would always come is like when you have a single source of truth, right? Say you're only modifying a piece of it. Like, I'm only like saying I'm modifying, like, I have like this 20 properties or 50 fields and only one property changes in that, right? Historically, like, there is like a performance implication because like now you're rebinding and so the whole thing has to like update, right? And that tends to be expensive. There were solutions for it, right? Like especially in the recycler view days, like, and they had like the diff, I forget what it's called now. Like,
Diffutil or whatever.
Yeah, exactly. Like, the thing that helps you say, oh, just update this piece because somehow I figured out that only this piece is changing. How does that work in Compose? Is that something that we have to manually do again with like a diffing logic, or is that magically taken care of?
Yeah, I can answer that, but I just wanted to make a point, which is Kotlin got all the best practices we had in Java as first-class citizen. So if you look at effective Java, most of the items there are first-class citizens of Kotlin. I feel the same way about Compose as well, where all best practices that we had to work so hard to get in the view system, they're baked into the system itself. So you don't have to worry about it. And so during one of our earlier conversations, I mentioned that you want to make sure that you send the bare minimum needed to a composable function to make sure that it's performant. The reason this is interesting is because the parameters of a function represent its identity. And so anytime a parameter is changing, we are essentially letting Compose know that something has changed. So this composable needs to be redrawn. And this is at a very oversimplified fashion is what is happening. Compose takes this one step further. And so I actually wrote a blog about this topic. I call it what is donut hole skipping, which makes Compose very unique. By the way, Leland and Chuck, who both work on the the Compose compiler, they created this concept, and I think it's mind-blowing, and also what differentiates Compose from any other declarative system, whether you compare it with Flutter or React. Compose is able to redraw just a single composable without having to redraw its parent or even its subtree. And so what tends to happen in the other view systems is that the runtime or whatever is powering this mechanism will find the smallest subtree that needs to be redrawn, and it will redraw that smallest subtree. What Compose is doing is that it's finding the smallest set of nodes that need to be redrawn without actually redrawing even the subtrees, which is very interesting, and it shows how much more performant it can be. Because if you're writing your entire app in Compose, let's say, you don't want to draw the entire subtree of your root node chain, right? Maybe you don't even need those properties because it requires just the parameters as its identity. It's able to smartly optimize it. There's also something in Compose called composable scopes. I don't think we have enough time to get into that, but my blog does cover that.
Okay, we'll definitely link your blog in that. So definitely.
Okay, so I'm super excited. I want to go build my entire app in Compose now, Vinay.
Go for it.
Is it ready for production though? Like, is this something that I can do today? Or would you say, hey, because I know it's like an alpha, it's beta, it's changing constantly. Yeah, but can I do this today? Like, would you suggest it?
Unfortunately, the answer again is it depends. And the reason I say it, the reason I say it is that a lot of companies are actually using Compose in production today. I do not want to speak for my employer, but I can definitely say that there are tons of companies that are using it in production. And we actually did a video with Google recently where we spoke about our experience of using Compose. So it's being used in production without a doubt. I think what you need to take into account is how it's solving your problems. Ultimately, your users of your app do not care about whether you use Kotlin or Compose. So I think it's very important that you use that lens first and justify it, because even if you want to use it, does not mean that you will have buy-in from other people in the company. And so you need some hyper motivated individual to start that conversation and figure out what the gaps are, what the risks associated with are for your use case specifically, what you stand to gain and what you potentially stand to lose. It's also possible that you've built so much infra that you're going to take some time before you can actually support it across the company. And so, again, I would encourage you to start having those conversations. Now is the time, because the writing is on the wall. It's very clear that Compose is going to be the default way to build Android apps. Whether you start doing it now or later is a slightly different and a more nuanced question, but you should be investing in it. That I can say I have strong feelings about that you should absolutely be researching, investing, hopefully experimenting with it.
Makes sense.
Wow. This is a ton of great information. Thank you, Vinay.
It was an honor to be here. Thank you for having me.
No, it's our pleasure. We'll try to pepper in like the blog post, the links and all of the stuff. I mean, we can go for another hour easy. Trust me, like there's so many things that like we can. We'll just have to bring Vinay back to the podcast another day and jump through some of this stuff. Vinay, if folks want to reach out to you, if they have questions about like some of the stuff that you mentioned, or like if they have questions that we have not covered, what would be a good way to do this?
I think my platform of choice these days is Twitter. That might change 6 months from now, but for now it's Twitter. And my handle is pretty simple. It's my first name and last name. So Vinay Gaba, Vinaygaba.
Perfect. And Donn, if folks want to reach out to you, what would be a good way to do it?
You can either reach out to me either via Twitter or Instagram on the same handle, which is just the same thing as Vinay, first and last name together, Donn Velker. What about you, Kaushik? How can people get a hold of you?
Similar to the other folks, Kaushik Gopal. That's like the same across like most places. That's where you can get a hold of me on Twitter, on GitHub, on Instagram. I've managed to keep that handle. Thank you all so much for listening, Vinay. It's always a pleasure. I know we chat in person and I have like the most fun conversations, and even those land up going for like multiple hours. We hope you come back, and thank you so much for sharing all this and for all the stuff that you've done to sort of popularize Compose in the Android community.
I had a blast chatting with you. Thank you so much.
All right. Thank you all so much for listening, and we will catch you all in the next episode. That's it for the show, folks. Fragmented is hosted by Donn Felker and me, Kaushik Gopal. We edit and produce all the episodes here on Fragmented. You can find more Fragmented episodes at fragmentedpodcast.com. Thanks for listening, and we will catch you in the next episode.